fellow scientists. My name is Izzy, and I'm a PhD student here at Wake Forest University. Thanks for joining us for Science Hour. So, let's talk about our ingredients here. Pretty simple ingredients. Actually, all of them are household ingredients. We have hydrogen peroxide, we have yeast, food coloring, and dish soap. Alright, so today, we're actually going to do one of my favorite experiments today. We're going to make bubbles, but not just the regular bubbles. We're going to make a lot of fun bubbles using hydrogen peroxide. Now, let's talk about the science before we do it. Put these off to the side. Now, you might recognize this bottle. What did you say it was? 3% hydrogen peroxide? That's exactly what it is. Good job. Hydrogen peroxide has the molecular formula of H2O2. So it's just like water, but with one more oxygen, right? So think about it. H2O is water. It's actually H2O1, right? Because it's one oxygen. But if we had two oxygens, or one more oxygen, we get H2O2. So that's what this is. Now, it's important to know that H2O2 actually breaks down over time. That's actually why it's contained within these dark bottles, so that it's protected from light. Light actually helps decompose H2O2 into two different molecules. What are they, you say? Well, H2O2 breaks down into H2O, water, and you guessed it right, oxygen gas. All right. So that's what we're going to do today. We're gonna speed up the decomposition of H2O2 into water and gas. Now this happens on its own over a long period of time. But unless you want to sit here for a few days watching it decompose, I vote that we use some kind of catalyst. Now, if you remember from biology or chemistry class or science class, a catalyst is something that helps speeds up the rate of a reaction by lowering the activation energy. But we won't go into all the details about a catalyst and what it is. But just know that if we did not have a catalyst, the decomposition of H2O2 into H2O and O2, right, oxygen gas, this decomposition reaction would actually take, I don't know, weeks, if not months, maybe years. But we're going to decompose all of it right here in front of our eyes in less than 10 minutes. Less than 1 minute. Before we get started, I do want to recommend three things. Let's recommend an adult in the room. Mine is over there in the corner. You can't see him, but he's here. And I recommend gloves that I put on backwards. And some kind of personal protective equipment for your face, just in case it's a messy reaction. All right, let's get started. So this is our H2O2. We're going to need yeast. We're going to need food. There goes the food coloring. This is why we need our adults. Adults, can you pass me the food coloring? All right, so I would recommend about 10 milliliters, a few ounces perhaps, probably like 50 mils of water, warm water. We're going to open our yeast, and we're going to take about a teaspoon to a tablespoon's worth of yeast. I don't have that, so we'll guesstimate here. All right, let's say it's about enough. Mixed in. I'm going to cap that. I've already added my hydrogen peroxide into another mason jar. We're going to add our food coloring. Let's say a few drops. All right. And then we're going to add our dish soap. A little bit, a little squirt of that should be all right. Now, that we've got these two things ready, we're going to go ahead and mix this yeast into the H2O2, dish soap, and food coloring combination. Let's see what happens. Ooh, there it goes. Now stand back and don't touch it because it's actually really hot. This is this reaction happens so fast and it's so favorable, it gives off heat. And this is called an exothermic reaction. So at this point, we're probably okay to just pick it up, clean it up with our hands, because it's simply dish soap, food coloring, water, and oxygen gas. Thanks for joining us today on Science Hour, and remember this, you don't need a fancy lab coat, or fancy goggles, or fancy gloves, or fancy equipment to be a scientist. You just need to have a question, a hypothesis, and then run an experiment and see what happens. See if your hypothesis was right and analyze the results. All right. Well, thanks for joining us. We'll see you next time.